So I cannot explain all the relational expression here. So why don't you study by yourself using the textbook? At least you should be able to understand the relational algebra expression in the textbook. Okay. So next one is Curie tree. We will see the Curie tree after midterm exam when we discuss about the Curie optimizer. Okay. The next one is the relational calculus. Which one do you like, the calculus or algebra? Actually, it's the same thing. Algebra is the before calculus, right? So that is the algebra. But in terms of the relational operation, did you take the calculus in your high school? Good. So calculus and the algebra are not the exactly same thing, but mostly it's the same direction. So when you learn, before you learn the calculus, you learn the algebra, right? Or sometimes you can take the pre-calculus, right? So, but it's a similar, but not exactly same in terms of the database model, relational database model. The main difference between the relational algebra and calculus is calculus. Why don't you think about this one? So when we have this number, what is this number? It's a natural number. 1, 2, 3, 4. This is the notation by kindergarten student. Kindergarten student learn such a way. But if you complete the elementary math, there are two ways to represent the natural number. One is this one. Another one is x bar x. X is bigger than 0 and x is positive integer or natural number, whatever. You can explain the condition. This is a conditional way. Calculus, relational calculus is like this notation. So anyway, when we access the data in relational model, we do like to define what? Many conditions. Sometimes join condition, select condition, and something condition. So why don't we combine all condition and specify here? That is the calculus. So in relational calculus, this is like this way. So T bar and condition. So using relational calculus, we can easily understand what is the condition to specify the data. Okay, that is the calculus, relational calculus. So what about the relational algebra that we have covered? Relational algebra show data source and how we are accessing the data. First, the relational algebra operation here. So like this one join, then this one. It shows the procedure. It shows the way to access the data. So if you are interested in only the condition output, you can use the relational calculus. Otherwise, if you want to see how we can access the data, we can use relational algebra. So relational algebra is frequently used in DBMS system, Curie optimizer and Curie processing, because it shows how we can access the data. We will see more in details after midterm exam. So for example, this is an example of the relational calculus. So T, the first name and last name, but condition is, and T salary is, so only show the condition. Okay. Also, we can use any notation that we learned in the set theory for all or exist. So exist and all, like this one and this one, in the relational calculus. But I'm going to skip this part. So in database design and the database system, relational algebra is more important. Okay, so that's pretty much the end of the chapter? Is it part of the homework, Neymar?
It's already done.
It's already done? Okay. So, the next one is database query. So probably, even though you never use the database, you heard about SQL, SQL, because it's one of the most popular computer languages used in the database. It's sometimes called SQL, but mostly SQL. But when I learned the database language the first time in my hometown in Korea, so most of people call this one is SQL, but here it's a SQL, but it doesn't matter. So its name structured query language. So anyway, the database system is running on the computer. There is no other way to communicate with the computer without language, programming languages. So that is a reason in computer science you probably learn the computer language first time, CS 101 and 102 with some basic data structure. Okay, without understanding, without using such a computer language, it doesn't make sense. So database is the same thing. So anyway, our goal is to build a database system on top of the computer. So we need a language that is a structured query language that is only for what? Relational database model. Relational database model, specifically this structured query language is an implementation of what? This. So probably, even though you never used the SQL, you heard about select from where. Very, very popular the clauses used in the SQL. Anyone who never seen the select from where? Probably you heard about this one. It's a very simple to learn. Why? Because we already covered this relational algebra. So when people develop the database management system, what is the DBMS? What is the difference between DBMS and database model?
DBMS is software.
DBMS is software. Based on what? Database model. This is the database model. This is a DBMS, part of the DBMS. So when they implement such a database language, selection is here. Then is table name, the relational name, go to here. And this one, go to here. And this list of the column goes to here. And set operation is additional operation for another select from where. And Cartesian product is the where condition. And join condition goes to here. And join, equijoin, and other join is additional. So actually this select from where are based on this. It's just combining all of this relational operation in one very simple query language. That is the reason it's very simple to learn. Okay? Even you understand what is the organization of such a relational operation, so it's just a piece of cake to learn. Okay, so in chapter 4 and 5, we will see basic query language and a little bit advanced query language, database language in this class. Before that, how many of you have installed any commercial DBMS by yourself? Anyone who have installed? Yes. What kind of DBMS did you install? SQL Server. Okay. Any other who installed MySQL or the Oracle database? Okay. When I learned, yes, Oracle, then what did you do? For what? Any specific purpose?
Just for my undergraduate,
Uh-huh.
sorry, my English not very good.
Yeah, it's okay. Don't worry.
Human resource system.
Mhm. So after you install the Oracle database, so which version of Oracle database did you install?
I'm sorry.
What version of Oracle database system did you install? Oracle 11 or Oracle 10?
Oh yeah, it's 12C.
12C. Then after you install, what did you feel? It's very successful, or what did you feel after you complete the installation?
No, it's a little different
Mm.
from others version because
Mm.
the username should
Mm.
have a C
Mhm.
sharp
Mhm.
like that. So at first it's taken a long time to
Yeah.
know.
So it's the same thing. So when I learned the first time the database system and any database, because my major was not the computer science, I never seen computer or I have seen the computer, but I never seen the database or even Oracle. I never heard that when I joined the IT department the first time. So I'd like to learn something about the Oracle because that it was my job. So I download the Oracle 7 at that time. So even though the company used the Oracle 6 at the time, so not much different. So I download and install myself. Sometimes it's a failed and reinstall. Then finally I can successfully install the Oracle the database. Then I feel the very confidence and very proud of myself. Then next thing, there's nothing I can do. That's it. If you do not have any specific purpose and if you do not know how to use that database system, there's nothing you can do, really. So feel very bad. Then go back to my supervisor and ask him any way to learn. Then at that time I start to learn the SQL language because without communication, so definitely I don't know what's going on. The others. So here the chapter 4 and 5 we will see based on such a relational model and the relational algebra operation. So we will see how to communicate, how to utilize the computer research for our data management. Okay, so to do that, I'd like to change it. So first thing what do you want to do after you install the Oracle database, after you cover the such an operation? What do you think what we can do using such a relational operation and DBMS system?
Create our own database.
Create the own database, which means, in other words, to build the house, my house, the first thing is you need to buy your land. Okay, at least if this is the 17th century or 16th century, anyway, you need to something to put the mark. This is my land, right? Otherwise, somebody will take the land or property. So at least you need to put something flat. Okay, as far as I heard that Western history, so you can not drive. Can ride a horse as much as possible, right? And put a flag that is your land, something like that. So you need to specify the area of your database, area of the property. So that is called the schema. So firstly, what you need to do is create the schema. So it's kind of the you limit. So what is a schema, by the way? It's a description of the database, right?
Metadata.
So metadata, this can be considered as a metadata. Anyway, schema means, based on our definition, it's a description of our database. In other words, to create our database, we need to create the schema, that description. So this is kind of the boundary. So inside nothing, but I'd like to specify this is our schema logically. But you can imagine it's kind of a physical boundary of our database. Like this one, this is a company, database schema. Within this, the area, I'd like to create the database using this, the database model. Okay? So that is the first thing you need to do. So how can we create the schema? Create the schema. Oh, one more thing is, when we discuss about the database language SQL, mostly it's very straightforward. You can intuitively understand the meaning of it. Sometimes even though you learn the specific syntax, you can imagine, for example, how can you create a table? Create table. How can you create the index? Create index. How can you create the, what else? User. Create user. Something like that. It's intuitively, so you can imagine. So because the database language is not very old language, it's a kind of new one. Also, it has been standardized a lot from the 1986. Okay, many people get together who have been involved in the database research or the database management system. They get together and make the standard. Unlike the other, model or the other language, other area of the computer science, they started earlier to standardize such a database language. The first one was the 86, the SQL 1 standard. Next one is the 92, it's a SQL 2 standard. The latest one is the SQL 2003. This is good because that means if I know one of the database languages, not one of the the database language, relational database language using the current DBMS system, almost the same to other DBMS system. For example, you know how to use Oracle. That means you should be able to use DB2. So if you have used, sometimes I got a question from the student. I have been used the SQL Server for my project and for my work, so I try to use only the SQL Server. I have used the MySQL, so can I use the MySQL for my project? Yes, you can do that, but I do not allow. So to be fair with the other student, if you have experience to use any of that, it's not a big deal. It's just a piece of cake to catch up other DBMS systems, as long as they are based on the relational model because of such a standardization. Okay? So do not ask, can I use the other DBMS or local database? No, only Oracle database installed in the UB server. Okay. Another reason is if you are using the local server, sometimes you don't know, you do not understand the basic mechanism how to connect the database in terms of the client-server environment. Because many of them are component-based. If you are using the Visual Studio or the SQL Server or the .NET environment, you don't know how to set up. You don't have to worry about that. Is the purpose of such abstraction level, high-level language. So I try to. That's one of my goal to make my student painful as much as possible. So try to connect the Oracle database. It's not very big problem. So as long as you can understand the client-server architecture. So because of that, database language is not very complicated or variation. However, because of this, database has a huge problem. As you can see, I will not mention over here, from SQL 2003 standard, this is not a free standard. What does that mean? These are the free standard, but this is not. What does that mean? You need to pay. For example, I developed my own relational database management system based on SQL 2003 standard. So which means my DBMS support the SQL 3 standard like the XML or closed function in the relational database model. However, to make my system commercial, I need to pay the money to that standard organization. Why? I believe it's kind of cartel of the commercial DBMS system vendor, including Oracle, DB2, IBM, and CBS, SQL Server, Microsoft, they don't. It's a big market actually in computer, the IT, the market. It's a big market. It's a big part. They don't want to lose their market share. Okay, so there are a lot of free open source database systems. It's not a very difficult project to develop the new DBMS system. Okay, it's much easier than the operating system. You can just follow the standard. So they don't want that is the reason Oracle actually possesses a MySQL, such an open source community even. Okay, so that is another reason. Because of that, the culture, it is very, very hard, okay, to change the model of the database. Right now, think about your program language. Do you use the C language? No. Do you know? You know?
No.
So, like most of the program language is based on the object-oriented concept. Think about your programming environment, ID. Nowadays, there's your software engineering, you are using the UML, use case modeling. Most of the computer science use such an object-oriented concept, except database. Database still use the relational model, which is totally different concept to deal with the data. Data, it can be viewed as an object in object-oriented concept. In relational model, it's just group of data. It's not record by record. That makes the difficulty to develop the database program. You need to consider two different data structure. So, because of this, so database, many academic, the researcher, they left from such a community. They don't care. So still the same level. Very hard. That's good news for me. I can still use the relational database in my class because it's one of the most popular one. So we can create after we create this one. But have you ever created the schema after you install? Is there anyone who create the schema? No, probably not. Nobody create. Why? Because if you do not create such a explicitly the schema, your username will be automatically default schema. For example, my username is JELEE. So if I do not create the schema, then create the table, index, or whatever, then this will be JELEE schema automatically. Okay, that is the reason 99% of the database user, commercial or the real project, they use default schema. But you can provide both the permission to other. For example, I have another user who is the namer, but namer does not have the permission to access this because it's a different the schema, different database. So I need to give the permission for her to use this one or to access this. Okay, that is the schema. So don't worry, even though you do not create the schema, your username will be default schema of your database. Then, before we learn how to access the data, before we use the house, we should create the house first, right? So that is the first thing, to create the table. It's the same thing, how can we create table? This is called reserved word. When you learn any program language, you will see what is a reserved word, what is not. So in database, so we have the reserved word. Is it the case sensitive? Yes.
No.
Yes. As I said, no case sensitive in database language. So it doesn't matter whether create, even though you type the lower letter, there is no problem, as long as it's satisfied with the syntax. So, however, in general, many of the project managers use the capital letter for such a reserved word or something like that. Then, table name. So, reserved word, create table name, and parentheses. Then you can list up the column name that you define in your relational model. Very simple. Okay? So then, two more things.
The last one.
Any database language end with semicolon. Semicolon means it's the end of statement. No matter how many lines, semicolon means it's the end of statement. That's the first thing. And second thing is the list of the column can be separated by the comma. Inside comma, you can see column name, attribute name, and space data type. Instead of the domain, we are not going to use the domain in SQL. Instead, we will use the data type. Next class, we will see more details about the data type. And if any, it's optional. If any, you need to specify constraint, condition, like the non-null, or the primary key, or the foreign key, or default value, or check. So any constraint will be specified. So very simple. So you can, next class, so you don't have to be here. We have the second exercise lab. In the 163, we make the two groups. So if you are assigned the first group, you can be, is it 12, 15? 12, 20. Okay, 12, 20 at the time. Your username and password should be available. If you do not receive the email, did you send the email to the student? If you do not have the Oracle username and password, especially those who registered lately, okay? I think who registered second week or third week, contact the GA and try to get the Oracle username and password. Without username and password, you cannot participate in the exercise line. Okay? That at that time, even though I do not cover the many of them, it's just straightforward. So there might be no problem to do your exercise line on Thursday. Any question? Okay, thank you, and we will see you on Thursday. And next week.